All right. It is Thursday, October 14th. This review slide is from yesterday. I was not here yesterday, so we're going to review what we've been talking about. We're talking about, is this fraction more or less than this fraction? So for number 1, we have 1/2 and we have 6/10. What can we do to solve this? What is an idea, Lila?
A number line.
Let's draw a number line. Great idea. I'm going to draw my first number line in blue to match with the 1/2. So when I have a 1/2, what do I need to do to that blue number line? What do I need to do to that blue number line? Nikki?
You need a
Let's split it in half here, and this stands for the 1/2 mark. Is that correct?
Yes, ma'am.
So I'm going to leave that like it is for right now. Now, 6/10. Here's what I'm going to do. I'm going to directly draw right on top of this, and I'm going to put my 6/10 number line right on top of that blue 1/2 number line. How many spots do I need on my number line? How many sections do I need, Olivia? What fraction are you drawing a number line for? 6/10. Mirror words.
Mirror words.
The denominator is.
The denominator is.
The total amount.
The total amount.
Of equal parts.
Of equal parts.
In a fraction.
In a fraction.
The numerator is.
The numerator is.
The number you have.
The number you have.
Mirrors off.
Mirrors off.
So this denominator tells us that our number line means how many equal parts? 10 equal parts. So there's our 10 equal parts. Now, how am I going to place 6/10 on a number line? How am I going to place 6/10 on a number line, Bradley?
Count 6 tally marks.
6 tally marks. Do I start with this one?
No.
Why not?
Because if you don't count 0.
Very good. Let's count them together. Ready?
1, 2, 3, 4, 5, 6, 7.
Whoa, almost everyone stopped at 6. Why do we not need the 7? Why do we not need the 7, Charles?
Because we just need the 6/10.
We just need the 6/10. So here is my 6/10. Here is my 1/2. Now, look at your paper and see if what you did on your paper matches here. Because I did ask you to explain or show your reasoning. So I'm going to take my blue highlighter and I'm going to highlight to the 1/2. And then I'm going to take my green highlighter and I'm going to highlight to the 6/10. And so that tells me that 1/2 is more or less than 6/10. Lila?
Less.
Why do you know that 1/2 is less than 6/10?
The 6/10 is it's longer. It's
Longer. What else could she have said? The 6/10 is
bigger.
bigger. The 6/10 is
Larger.
larger. The 6/10 is
More.
more. Very good. 6/10 is more. Therefore, we know that 1/2 is less than 6/10. We could also write it like this. Right?
Yeah.
All right, let's do 11/12 and 1 very quickly. So 11/12 is going to be purple. 1 is going to be orange. Can I start with the 1 just because it's so easy?
Yeah.
0, 1. How much of the fraction is 1 on this number line? How much of this number line is going to take up, Levi? It's kind of a trick question. How much is the 1 going to take up on this number line?
Well,
Don't. Yes, but let's just talk about it like this. Oh. Let's just talk about it as a 1. How much of the number line is the 1 going to take up? I drew the number line. I have a 0 and a 1. The whole thing. Very good. Yes. Yes. I told you it was maybe a little bit of a tricky question. My apologies. You forgive me? You sure? So 0 and 1. Now this I'm going to work here. 11/12. Levi, how many tick marks do I need?
12.
Very good. Is it important for my tick marks to be as close to equal parts as I can get them?
Yes.
I don't want to make my number line like this. Right? That's not going to work. Does it have to be absolutely perfect?
No.
I'm never going to get it absolutely perfect because I'm not a computer. But I'm going to try to get pretty close. Now, how am I going to count? Ashley's on here. Emmy, what am I looking for here, Emmy? On the purple. What am I trying to point? What point am I trying to represent? 11, 12. So I'm going to start at the 0. And how many hops do you want? How many hops do you want? How do you know that? Excellent. So let's count with her. Ready? 1,
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Good job. Most people stopped at 11 this time. Excellent. 11, 12. So I'm going to take my highlighter here. I'm going to highlight all the way to 11, 12. And then in my orange, I'm going to highlight all the way to 1. So is 11 twelfths more or less than 1? Charles?
Less.
Less than 1. Very good. How do we know that? Ella?
1 whole has more.
1 whole has more. If we had 12 tick marks, how many do we need to make 1 whole? Levi?
We need 12 tick marks to make 1 whole, but it was 11 12, so if we would have had 12 12, it would have been equal.
That's exactly right. So this is a good thing to do because it did tell us to explain or show our reasoning, but we know that 11 twelfths is smaller than a whole because we know that to have a whole, we'd have to have 12 twelfths, right? Good job. You are correct, my sir and ma'am. Very nicely done. Okay. We are going to our new lesson today. Fractions, equivalent fractions. Let's find some equivalent fractions, shall we?
Yes, we shall!
Here we go. Decide if each statement is true or false. Be prepared to explain your answer, your reasoning, excuse me. So, I want table 1 to do the top one only. And all you're doing is deciding if the statement is true or false. That's all you're doing. Table 2, this one's yours. 3, 4, 5, 6. A good way to start the conversation would be some noticing and wonder comments. What do you notice and what do you wonder about these things? Go to work. You have 1 minute.
It's not easy. 1, 2, 3.
I like what you're trying to do here. What were you going to say, Ella?
I say true.
What does that mean? They are. Say again. Okay. Good. Pax deuces all over town. Very nicely done. Table 1. What do you got?
So you said that 4/8 is equal to 7/8, so it's true.
This is true. Okay, table 5, what do you think?
It's false.
Okay, so table 1 says it's true, table 5 says it's false. Who is going to prove themselves right? Why do you think that, table 1?
Because we noticed that the denominators are the same.
And what does that mean?
It means that they're not the same.
Here's my number line. 8 eighths. 1, 2, 3, 4 eighths. 1, 2, 3, 4, 5, 6, 7 eighths. Who's going to change their answer? You guys or you guys? You guys are going to change? Why, Mackenzie?
Because there's 7 marks, but
Okay. When we have a denominator that's the same, that's telling us that we are cutting these pieces into the same amount. So if I have 8 pieces that are cut into the same amount, and I have 4 of them, and I have 8 pieces that are cut into the same amount, and I have 7 of them, those two things cannot be equal. Because when the denominators are the same, then we're only concerned about the numerator. And so, when I say something is not equal, I can just draw a line through that. We have learned these 2 inequality symbols so far, right? This is another inequality symbol. An equal sign with a line. That means that is not true. That is false. That is not equal. That does not work. That is not the right thing, right? So, good job, table 1, for correcting your answer. Well done, girls. Good job, table 5, for having the right answer in the first place. Very nice. Okay, table 2. What do you got for 3/4 and 6 eighths? True or false?
False.
False, they say. Table 6, what do you say?
True.
True. Oh,
Yay.
more disagreements.
I love it. I love hearing
More disagreements. What do you think? Let's see. What'd you say? True? What'd you say?
False.
Wait. No. What'd you say?
True.
True. And you said false. You talk to me first. Why?
Because they wouldn't be equal if one number line.
So you're saying if I draw another number line that has fourths, 3/4 is not going to hit in the same place as 6 eighths. Is that what you're saying?
Yep.
Can I use this eighths number line to draw fourths? Huh? Okay. So here's the half, which would be how many fourths? The half for fourths? This 4/4 is going to be the whole thing. Colton, what's the half going to be for fourths?
2.
Huh?
2.
2 what? 2/4. And then where am I going to have to draw my next line to divide this number line into fourths? Levi? Right now I have 2 orange sections. I need 4.
3 probably on the second one.
This here?
Yeah.
Yep. So what's this tick mark going to be called?
1/4.
Good. What's this one going to be called?
3/4.
What's this tick mark called?
1/8. 2/8. 3/8.
What are you thinking, Raylan?
It's true.
Ah! Are you guys right? Because here's my 6/8 right here on this line. Here's my 3/4 right on this line. And when I have my two things that line up like this, that means that they are equal. They are equal. That is correct. Good job.
And three is half a 6, and 4 is half an 8. And the two numerators are smaller than their denominators.
Very good. They looked at these fractions like this, and then we confirmed that with the number line. Very good. Table 3. Go, Olivia. You said that this is false. Why did you say that?
Because
2 6s is going to be less than 2 8s. Well, let's do this one with magnets. We have 2 6s here. And we have 2 8s here. Michael, I'm going to draw these on for you, okay? So you can see them. So here's my 6s. Here's my 8s. If I have two numbers that are cut into different sized pieces, so like 6s, if I have 2 6s, is there any way possible for that to be the same size as 2 8s? No, because we got two different size number lines. And if our numerators are the same, but our denominators are different, that means that this is cut into 6 pieces and this is cut into 8 pieces. And we're allowed to use our little comment if the denominators are, wait, no, that's not how it goes. The smaller the denominator, the bigger the piece. So, are these things going to be equal? No. Table 4. What do you got? 6/3 and 4 halves. Table 4?
I said that,
I said or we said?
we said that 4 2s
4 halves?
would be like saying if you had 4 2s, like 4 times 2, basically, and that it would equal 8 wholes, and the other one would equal 18 wholes.
You want to try to confirm that with a number line? Let's draw this out with a number line. Let's draw this with a number line.
I'm gonna go to the doctor.
What?
I need to get off. Bye.
Okay, bye. Let's confirm this with a number line. Braylon? Blue for the thirds, green for the halves. Deal? What are we going to cut this number line into? 3s. So let's label it. This first one is 0, and then this is going to be?
1/3.
Yep.
2/3. And 3/3.
Now what?
We don't have 6/3, so we make another.
Good job. Now, can my number line be like this? No, it has to be what?
Inside.
It's got to be the same size here, right? Come on. Come on, Mrs. McGinnis. Get with it. It can't be that big. Got to be about the same. Is that pretty close?
Yeah.
Pretty close. Close enough. So this is 3/3. What's this one going to be?
4/3.
4/3.
5/3. 6/3.
3/3 equals 1 whole. So 6/3 must equal 2 wholes. Good job. Now, let's take this right here, this orange one right on top. Here's my one orange number line. What do we need? Oh, man, it's supposed to be green.
Good job.
So what do we need to divide our number line into? How many pieces? Which one tells us? 2 parts. So a half here and a half here. So this is 0. What's this line? 1 half. 2 halves.
3 halves.
3 halves.
4 halves.
4 halves. If 2 halves equals 1 whole, then 4 halves is going to equal
2
2 wholes. Which now what are we at? So here's 4 halves. Here's 6/3. What do we got, Nikki?
They're equal.
They are equal. Raise your hand if you see that they are equal. Excellent. So when we are finding equivalent fractions, we are working together with number lines and numbers to determine whether they hit the same spot. Very nicely done. Okay. 22 minutes. My recording is only allowed to be 20 minutes long. Yeah, it was 22 minutes, so it's 2 minutes too long. So I have to get my teaching down less. All right. For the pair of fractions that you know are not equal, can you tell which fraction is greater? How? So let's go back. These ones are not equal and these are not equal. Can we tell which one is bigger? Can we tell which one is bigger?
Yes.
How can we tell?
Because there's one of them have 2 lines and one of them has a cross.
Right, but can we tell which one is bigger, 4/8 or 7/8? Can we tell? Ella?
Yes, because if the denominator are the same, we have to look at the numerator and see which one's bigger.
Very good. And what else could we use to determine whether it's bigger? Sophia? Looking up here. What else can I use to determine which is bigger? The picture we drew, right? We drew a picture for this one here too. We used tiles. We can determine which one is bigger based on the pictures we draw. All right, now we're going to be generating equivalent fractions. Each entire diagram represents one whole. We're going to write 2 or more fractions that the shaded part of each diagram represents. Look at letter A. Raise your hand when you have a fraction in your mind for letter A. Can't look at letter A if you're not looking up here. Raise your hand when you have a fraction for letter A. Colton, what do you got? 2/8. Is he right?
Yes.
2 shaded. 3, 4, 5, 6, 7, 8. Good job. What fraction we have for B? Levi? Huh? Yeah, you do. Denominator is the total amount of equal parts. What is the total amount of equal parts here? 6. And how many are shaded?
2.
Very good. Don't quit on me. You don't have to quit on me. I won't leave you. Right? Letter C. Who has something for letter C? Aubrey.
2 tenths.
And letter D. Who has something for letter D? Bradley?
8/12.
8/12. All right, so 8/12. Now, we have one fraction for each, but they asked us for 2 or more. What can we do to write an equivalent fraction for each of these? What could we do to write an equivalent fraction for one of these? I'm going to draw sticks because you guys are You guys are trying to not be with me. Raylan, Cornut, what's something we could do? You can pick any one you want to write an equivalent fraction for out of any of them.
We can divide B into 3 parts.
So 3 equal parts. That would be 1, 2, 3. Is that correct?
Mm-hmm.
So I'm going to draw this kind of like a box. Sort of like putting a number line on top of another number line, only they're using a diagram instead of a number line.
Mm-hmm.
You tracking with me? So if I color in all of this, Raylan, how many thirds am I using for 2/6?
1/3.
1/3. Very good. Excellent work. Who else has something for another one? Aiden? On what?
Number 8.
Oh, this one? Okay.
You can make a box of 2.
Like this again?
Yeah.
So I have 2 in each section,
Yeah.
which is going to make my denominator be what? Good job. And when I color in the same shaded section, how many fourths do I have?
2.
2 fourths. This is a fourth. This is a fourth. This is a fourth. And this is a fourth.
4
4 fourths would be one whole thing. Each entire diagram represents 1. 1, 2, 3, 4 fourths is the whole thing. How many fourths do I have here? Help a brother. Bradley.
1/4.
He got it. He beat you to it, Bradley. 1/4. I've cut this into smaller or bigger sections. I've put these together. Hey, guys, you have to be looking up here and listening. So now I have 1/4. C or D? What do you want for C or D? Ella? Ella Davidson? Huh? You want to cut this one into fourths? This one here? So 1, 2, 3, 1, 2, 3, 1, 2, 3. Do I have equal parts here? 3, 3, 3, 1. No, I don't have equal parts. So I can't do fourths. What else could I try? Bradley, try to help again.
2 and 2.
So if I'm going to do that, how many have to be on each side? Oh, wait. How many sections of 2 do you want? Is that what you mean?
Yeah.
Sections of 2? So how many sections of 2 is this, Bradley?
5.
5 sections of 2. Very good. How many fifths do I have shaded here?
2.
Those are tenths. That's 2 tenths, huh?
1.
1. Good. Now what are we going to do down here? Charles?
Maybe we can put 3.
Now we have 4 equal sections, but is the shaded part match up? Nope, so we can't do that. What do you want to try, Nikki? One, 2, 3, 4, 5, 6.
You should in 4 of the 6.
Shade in 1, 2, 3, 4. Right? 4 6s. Who agrees with letter D? Good. Hey, I want to do something up here on letter A. I want to do this. So now I'm going to have 1, 2, 3, 4. For what? For what? I just took these 8 sections and I put a mark halfway in between each one. So that gives me 4 what? 4 16ths. Very good. 4 16ths. We could have, yeah. We could have done it to this one here too. We could have cut this in half, 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 which would have given, if we started with 6, that will give us 12. How many 12s? 1, 2, 3, 4. 4 12s. Can we do it here?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. How many 20ths am I going to have?
420.
4 20ths. Very good. Could I do it down here too?
Yeah.
Sure. 1, 2, 3, 4, 5, 6, 7,
8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24.
24. How many 24ths am I going to have colored if I color 8 12s?
12.
Wait, dang it, I forgot it.
16, 24.
That's right. 16 24ths. Could have done it either of those 2 ways. Yes, Bradley?
I got an equal fraction of 2 eighths, 1
What?
of 1 fourth, so yeah, that.
Oh, yeah. It's up there. All right. Now, write 2 or more fractions that the point on each number line represents. We're not going to do all of these. We're just going to do one because we've been talking about number lines a lot. And today in our review slide, we talked about number lines a lot. So what does this point represent? Who can tell me what the point represents? Olivia? Huh? 1, 2, 3, 4, 5. 2 fifths. And what can we do to make an equivalent fraction? What can we do to make an equivalent fraction? Olivia, why don't you do this whole thing? Tenths. If we split all these in half, we could split them into tenths, and that would give us how many tenths? 1,
2, 3, 4, 5, 6.
Well, I'm stopping here at the point. So 2 fifths is the same as 4 tenths. And we could do that for these. This is, now notice how our ones are falling. We got different things. So what's this tick line here? 2 fourths, 3 fourths. What could be an equivalent fraction for 3 fourths? Ella?
4
No, these 2 things are separate. These 2 things are separate. This is not a match. We have to work this number line to make a match. We can't just look above it and find a number close. We got to work the number line. Rayland?
3 tenths.
This is a separate number line, guys. Ignore this. Don't look at this part. This is fifths and tenths. This is fourths. Ella?
2 6.
2 6. This 3/4 here, Ella? Huh? 2, 6. Are they going to hit in the same place on the number line? No? Gage?
You could do, 4, 8.
Well, let's do 8s. One, 2, 3, 4, 5, 6 8s.
Oh my goodness.
6 8s.
Because I think I know what.
All right. How is the process of finding equivalent fractions using diagrams like the process of using number lines? So the question is asking you, when we're finding equivalent fractions, we can do that on a diagram or we can do that on a number line. How are these things the same, using a number line and using a diagram? How are these things the same? Raylan? We can have a number line that has fourths, or we can have a diagram that has fourths. How are these things the same?
Because it's 4s and we can use 1 4.
Okay, good. Charles? Aubrey? They both have a 0 and a 1. When we mark down fourths, so let's say this is 1/4 and this is 1/4. I want to shade this fourth here, and I want to shade this fourth here. Do we shade both of them? We can. How are they different? How are they different? Raylan?
One's got a line and one's just a big box.
Okay, one has tick marks, one is boxes. Good. Ella?
One has 1/4 in it, and one has 1/4 above it.
Okay, very good. Very good. This is going to be very similar to your warm-up slide for tomorrow. I'm going to give you a fraction. So in this case, 5/3. And I'm going to ask you to write me 2 more fractions. 2 more fractions for 5/3. So here's 1/3, 2/3, 3/3, 4/3, 5/3. There's my fraction. What could I do? What could I do to label thirds? Let's do this with a diagram as well. Not very good equal parts in my diagram, sorry. What's a way that I could name an equivalent fraction, Raylan?
The box on the bottom in the middle.
Like this? And that's going to give me what? 10 what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is the whole thing. 10 12ths. Does that hit in the same place? So if I divide this into 1, 2, then this becomes 10 12ths. I want to think about this more. Don't forget what we have here. Don't forget what we have here. This is one whole. And this is one whole. So is our whole cut into 12ths? It's cut into what? 6. And how many 6s do we have?
2.
6. We have 10 6s. That was a close one. 1, 2, 3, 4, 5, 6. 1, 7, 8, 9, 10. 10 6. And so I'm going to ask you to come up with 1 or 2. I haven't decided yet. 1 or 2 fractions that are equivalent. I'm going to ask you to come up with your own equivalent fractions. Okay? That is tomorrow. So excellent job today, guys. See you guys later. This concludes our math lesson for today.